In the beginning, there was darkness, and then, bang, giving birth to an endless expanding existence of time, space, and matter. Now see further than we've ever imagined, beyond the limits of our existence, in a place we call the universe. What if the forecast predicted high winds 10 times the speed of sound? An evening downpour of sulfuric acid rain. Or a hurricane 2 times the size of Earth, lasting 300 years. This is not the stuff of a science fiction movie. These are actual weather reports from around the universe, and it's Earth's weather to the extreme. We are counting down some of the biggest, baddest, weirdest, and wildest weather the universe creates. Fasten your seatbelts, it's gonna be a bumpy ride. This is the universe, wildest weather in the cosmos. Weather is the state of an atmosphere. We might think we've got it bad on the 3rd planet from the sun, with vicious thunderstorms, oppressive heat, and temperatures so low they're sometimes unbearable. But weather here is a walk in the park compared to weather elsewhere in the universe. Rain, wind, and storms take on a whole new and strange meaning. And while the mechanics that power these weather events are strangely similar to Earth's, the results are terrifying to contemplate.
It's 900 degrees Fahrenheit on Venus, hotter than a pizza oven, every day. Mars is bone dry and colder than ice cold.
You've got lightning, you've got storms. All those weather phenomena are ultimately driven by the fact that the temperature differences created by uneven input of sunlight are going to cause motions in the atmosphere.
Perhaps the answers to Earth's ultimate fate lie in the great unknown of space. And we're counting down the most extreme weather the universe has to offer.
You want to learn about which way our planet can turn climactically? Have a look at some neighboring planets within our own solar system.
Scientists know all weather starts with one thing: heat. Heat is a catalyst that creates winds. And there are winds on other planets unlike anything Mother Earth has ever seen.
Jupiter is a monster planet. If you add up all the planets together, they would not total the gigantic planet called Jupiter.
Jupiter is the planetary amusement park when it comes to windy conditions.
Jet streams on Jupiter are pretty cool. Here on Earth, we roughly speaking have about 1 jet stream per hemisphere. Jupiter is different. Jupiter has about 30 jet streams. These are associated with the cloud bands.
Jupiter's jet streams rip around the planet, running in opposite directions. Defined by different colors and visible on its surface, these jet streams tear around Jupiter's astounding 1,000-mile thick atmosphere. Earth, in comparison, has only a few jet streams and an atmosphere only 100 miles thick. But why so many jet streams? And why winds at all on a planet that doesn't even get a quarter of the sunlight as Earth? One theory suggests these winds are a direct result of this hot planet just trying to cool itself off.
Jupiter's a huge planet, over 300 Earth masses, and it formed with a huge, huge amount of heat. And it's so big that it's still trying to get rid of this heat of formation.
This constant release of heat slowly rises into Jupiter's atmosphere and collides with cooler air. Like Earth and her need to balance hot and cold streams of air in high and low pressure systems, Jupiter also struggles for normalcy.
That energy then is used to drive the various storms and winds in the upper atmosphere of Jupiter. The jet streams on Jupiter are really ferocious. They go at several hundred miles per hour. And there's a lot of gas zipping along this stream. But unlike on Earth, the jet streams are pretty stable.
On Earth, it's rare for surface winds to reach over 200 miles per hour.
The jet streams on Jupiter reach speeds exceeding up to about 300 miles per hour.
That's really fast. And you can't get out. You're trapped inside the jet stream.
Traveling through Jupiter's equatorial jet stream would be like a roller coaster ride from hell.
It's like this continuous, never-ending roller coaster ride. I love it!
You would be pushed up and down by up to 100 miles. This is huge. It would lead to a much greater change in pressure than going from the Earth's surface up to the top of Mount Everest.
Jupiter's jet streams are pretty impressive, but 300 miles per hour is nothing compared to our next planet. At first glance, Neptune is the last place scientists expect to find wild weather, let alone vicious winds. Heat is not in abundance on this chilly planet.
Neptune is frigid, frigid cold. Neptune only absorbs 0.1% of the sunlight that Earth does.
Up until 1989, Neptune was considered, well, boring. Sitting far away from the sun and having an orbit of 165 years, scientists didn't believe much was to be discovered on the blue planet. A visit from Voyager 2 changed all that. As the orbiter zoomed past the planet, scientists were shocked to discover traces of clouds. Most surprising, these clouds were traveling around Neptune at ferocious speeds. Something was carrying them, but wind so far away from the sun?
Neptune is the windiest planet in the solar system. Winds blow on the surface of Neptune over 1,000 miles per hour. Imagine that, breaking the sound barrier every time you simply look up and the winds blow past you.
Scientists estimate winds reach up to 1,500 miles per hour, depending on weather conditions and storms that develop.
A major unsolved puzzle in our solar system is the fact that the wind speeds on Neptune are actually much faster than those on Jupiter, despite the fact that Neptune receives only maybe 4% of the sunlight that Jupiter does.
This lack of sunlight or heat completely contradicts what scientists know about how winds develop here on Earth.
You might think that the stronger the sunlight, the stronger the winds would be. This is obviously not true when comparing Earth to Neptune, since Earth's winds are typically maybe 30 miles per hour, whereas those on Neptune reach 900 miles per hour.
Scientists suspect there is internal heat left over from Neptune's formation billions of years ago, but are perplexed how this internal heat could be enough to drive winds to this speed.
There's twice as much heat getting out of Neptune as what the sun is putting in. However, that's not enough to explain the tremendous winds of Neptune.
And science has come up with another hypothesis for Neptune's racing winds. A lack of friction might allow these winds to fly uninhibited around the planet.
We can be very thankful that there's friction on Earth. Friction comes about when the winds are banging into things like trees and buildings and terrain like mountains. So friction ends up slowing down the winds.
Like other gas giants, Neptune has no solid surface.
Even though the sunlight is extremely weak, if the friction is also extremely weak, then you can build up very fast winds over time.
Neptune's winds are the most impressive in our solar system. But the universe is a big place, and what is a champion here pales in comparison to weather further out in space. Perhaps the most exciting discovery in planetary science are the most amazing winds we could hope to never experience. If you want to experience the wildest winds in the cosmos, then hot Jupiters are your destination. Hot Jupiters are a class of exoplanets.
It's definitely not a place you want to be. It's much, much worse than Neptune. It's much hotter, the winds are much faster, so if you want a nice kind of calm place to set up shop, you'd probably be better off going with Neptune. These guys are definitely much, much worse.
Hot Jupiters orbit tightly around their stars, far closer than Mercury to our own sun. And all that intense heat makes for some wild weather.
For comparison, it gets about 20,000 times more light from its star than Jupiter does from the sun.
The temperatures on these planets are enormous, at between 1,500 and 2,000 degrees Fahrenheit or more.
Some hot Jupiters are tidally locked, a gravitational effect that leads them to show the same face to their star at all times.
You've got one side of this planet that's being just blasted with light from the star all the time, and so you would expect that to be very, very hot. But at the same time, you've got this night side of the planet that never sees any light from the star. So, perhaps that night side is actually quite cold.
Taking hot Jupiter's temperatures, scientists measured how much light is eclipsed from the planet as it passes in front of and behind its star during its orbit.
So they actually glow relatively brightly at infrared wavelengths. So if you want to take the temperature of a planet, you want to look at these infrared wavelengths. You want to measure the heat they're giving off.
But the temperature difference between the day side and night side was virtually the same. This was astounding considering the extreme situation. Something was transferring the heat from the day side to the night side, but what? Winds traveling at amazing speeds were the answer.
And so our models tell us that the winds could be as fast as maybe 6,000 miles per hour.
The 6,000 mile per hour winds inferred on some hot Jupiters is much faster than any winds that we know of in our solar system.
How fast is 6,000 miles per hour? At that speed, you could travel from New York to Los Angeles in 20 minutes.
You've got this incredibly hot day side, and so you've got all this hot gas sitting there on the day side, and sort of what it wants to do is to kind of go rushing around to the night side.
Winds are created by hot air wanting to travel to the cold side of the planet.
So it's a little bit like a windsurfer. If you come out here on a windy day and you put your sail up, you can really catch a good breeze and you can go flying across the harbor. It's the same thing with these planets. You have such incredibly strong winds that they can really just pick that gas up and whip it all the way around to the night side before it even cools off at all. It's hard to beat weather like that. 6,000 mile-an-hour winds is about as crazy as you can get with a planet.
Scientists have learned to expect the unexpected when it comes to weather in space. Sometimes winds become storms, like tornadoes. And galactic tornadoes are unpredictable and behave in rather weird ways. Recently, a tornado of epic proportions was discovered in space. This space tornado is a Herbig-Haro object created by winds as the result of a forming star.
A Herbig-Haro object is a glowing cloud of gas produced when a high-speed jet of gas smashes into surrounding, essentially, stationary gas. So this high-speed jet heats the stationary gas and causes it to glow.
This object would easily be #1 on the list of wildest tornadoes in the universe, except for one important fact.
It's not actually a tornado. Its shape is very suggestive of a tornado. It has this helical shape to it that looks like it is twisting along, but it's actually not a rotating object like a tornado.
Unlike a tornado on Earth, where a vortex of wind creates a conical shape, this tornado is created by magnetic forces, creating a wake of cosmic dust and particles.
This one appears to have sort of a spiral shape within it. And that's really kind of weird because most of the others really don't have the spiral pattern. But the cause of the spin is probably different from that of a tornado on Earth.
#2 on the galactic tornado list is much more like tornadoes we find at home, and it's a towering presence. They're called dust devils, and they are Mars's answer to a planetary tornado.
Dust storms on Mars are pretty cool. There are thousands of local storms that occur every Mars year, meaning dust clouds that are opaque and maybe tens to hundreds of miles across and a few miles tall.
Often referred to as the red planet, Mars is a dusty and dismal place. Its surface is covered by sand. Apparently, there is no liquid water on the surface. And in this dusty terrain, when the sun rises, trouble starts. Dust devils can be hundreds of yards wide and a half-mile or more tall, spinning 70 miles an hour across the surface. And they have similarities to Earth's own tornadoes.
As far as the basic forces inside a dust devil, they're pretty similar to in a tornado. They're both thin vortices that rotate and are low-pressure centers, yet a tornado is much, much stronger, often by an order of magnitude in wind speed.
The power of a tornado is undeniable. And scientists at Iowa State University can't seem to get enough of these violent storms. Here, they have built the largest tornado simulator in the world to understand vortex formation. Understanding the power of a tornado on the small scale here might lead scientists to understand these beasts on a grander or even galactic scale. Scientists use dry ice and packing peanuts to observe vortex behavior.
There's a 6 feet diameter fan on top of me, as you can see, which produces the suction, and the flow goes up and comes through the outer duct, and it's rotating, and then the flow converges to the center and again goes up. And as it's going up, it produces the vortex of a certain size, which we can control.
Combined, these elements perfectly mimic the formation of a vortex as it swells from its base and grows to a funnel. Scientists know that just like tornadoes on Earth, dust devils form from the ground up.
Sunlight comes down and heats up the surface, and that heat needs to be convected away by hot blobs of air. As these hot blobs move away from the surface, air is drawn in, and just like an ice skater pulling in her arms, that air spins up, moving faster and faster, and with those higher speeds, kicks dust up into the atmosphere. As this hot blob of air moves away from the surface, the dust devil will become taller and stronger, reaching altitudes of several hundred meters or more and widths of typically 100 meters, and will get stronger as dust continues to be injected into its interior. And then the dust devil will move off into the distance.
However, if a future space colonist was trapped in a Mars dust devil, it wouldn't be fatal.
The atmosphere on Mars is very thin, so the wind could be blowing on you and you barely feel it. The pressure on you would be relatively low. So you're not going to say, oh, what was that? I just got bowled over by a dust devil. No, that's not going to happen.
The final galactic tornado event on the countdown is a true mystery, and it turns theories behind tornado formation upside down. The final tornado on the countdown is double trouble. Venus, once viewed as a romantic planet, has some truly horrific weather conditions. Oppressive heat, the greenhouse effect gone amok. This is one planet that is constantly trying to cool itself off with no success.
Venus is a fascinatingly hostile place. It's so hostile that even our machines that we send there, they work for like a few minutes, and then the components melt.
As a result of this constant heat, storms are always present on Venus, and this makes for one of the most interesting vortex events ever observed.
There's a giant, upside-down, twin tornado permanently existing at the pole of Venus.
Ever since the Venus Express orbiters sent back magnificent images of Venus, scientists have struggled to understand the twin vortexes running upside down at her south polar region.
In a sense, it's an upside-down tornado because the air is funneling from the top part of that spiral down towards the ground, whereas a typical tornado on Earth, you think of the air kind of rising up the funnel. And the strange thing is that it's a double vortex. That is, picture two giant tornadoes sort of rotating around each other, and you can see the two lobes, the two halves of it here.
scientists believe the vortexes are a result of heat transfer in the atmosphere. Heat rises at Venus's equator, then sinks at the coolest section of the planet.
Like a bathtub draining, where the water is, that flow is concentrated on the drain, and it leads to this spinning motion. Why it's a double vortex, we don't really understand. That is still mysterious.
This storm is an enormous presence on Venus. It's thousands of miles across. The winds it generates are hundreds of miles an hour. And these vortexes are a permanent fixture on Venus. Weather takes many strange forms in space. Even rain. But other planets have atmospheres made up of different chemicals. In turn, rain is formed from ingredients that would be lethal to humans. And these toxic rains are some of the worst you'll find anywhere in space. Far out past the rings of Saturn lies the second biggest moon in the solar system. Titan. In 2005, the Huygens-Cassini probe pierced Titan's atmosphere, landing on its surface. What it discovered was a place with features eerily similar to Earth's.
Titan is the only planetary body in the solar system that has seas, like Earth. In fact, I regard Titan as a deranged version of Earth.
Scientists were excited to discover mountains, washes, even lakes the size of Lake Superior. And the liquid that fills Titan's lakes and rivers isn't water. It's methane.
I wouldn't want to go swimming in one of those lakes. They're liquid methane, which is extraordinarily cold.
And that means when condensation occurs on this planet, it rains methane. Rain on Titan isn't an everyday occurrence. In fact, scientists have only witnessed cloud formation a few times. But the evidence is everywhere. Deep washes as a result of significant rainfall.
Here we are in Tucson. It hasn't rained for days, and it doesn't usually rain, but occasionally it rains very strong. And we get a lot of water coming through this wash and eroding this wall. This is the same kind of evidence we see on Titan, where usually it doesn't rain, but occasionally it produces phenomenal washes.
Rainstorms on Titan might be pretty violent. We see lots of erosional patterns on the surface that suggest that some of these storms have been pretty powerful.
Scientists believe it takes time for a storm to develop on Titan. And every once in a while, enough clouds build so a rainstorm occurs.
So what if we do see a storm here? What would it look like? Well, the big ones are incredible. They would cover the sky from one end to the next. And we would eventually start seeing these very gently falling drops, much slower than the rain that you have on Earth. In fact, everything would seem to be in slow motion. The winds would be a little bit slower, and the drops would gently land, and they wouldn't be water. They would be natural gas.
Imagine a toxic drizzle with the consistency of waxy crude oil, all at minus 300 degrees. That's Titan.
Venus, there's never an issue with getting enough heat from the sun. With carbon dioxide forever trapped in the atmosphere, it has a greenhouse effect gone wild. All that heat creates condensation and clouds. Thick with sulfuric acid.
Here's the irony. Venus is named for the goddess of beauty. The source of the beauty of Venus is one of the most potent acids known to science. In other words, women are not from Venus.
There seem to be storms and convection patterns that move around. There are places within those clouds that are very turbulent.
Rainstorms on Venus happen 30 miles up from the surface in the cloud beds. And acid rain falls constantly.
The thing about the acid rain on Venus is that it literally is battery acid. It's so strong, that acid, that it would eat through skin and do very nasty things.
So whatever's left of your body would be burnt into a charred piece of powder by the sulfuric acid.
But the final rain on the countdown is the most toxic, if not the most dangerous of all. Throughout the universe, failed stars called brown dwarfs hide in the shadows. While they're more massive than our largest planet, Jupiter, they are so faint, telescopes have trouble detecting them.
A brown dwarf is a failed star. It's a wannabe. It's a ball of gas that never quite made it. You have to have a certain amount of gas before you get ignition and you get a beautiful star emerging. A brown dwarf just didn't make it.
Despite being a failure as a star, temperatures on brown dwarfs are still pretty impressive. At over 3,000 degrees Fahrenheit. And unlike stars that are too hot to have weather, brown dwarfs have cooled enough to experience convection and condensation. At these temperatures, rain takes on a whole new terrifying meaning.
Deep in the atmosphere of a brown dwarf, it's so hot that even iron is a vapor. It's a gas, like water is in our own atmosphere.
As iron vapors rise up, they cool, solidify, and turn to sand.
And the iron would start to condense, and you'd have clouds, big puffy clouds, except the clouds would be sand, boiling hot, 1,500 degrees. Because in a brown dwarf, you have something the size of Jupiter, but you've packed in 30 or 40 or 50 times the mass of Jupiter. The gravity is very high. It could be as high as 300 times the gravity we have on Earth. And so things can fall a lot faster. The high moving velocity of the sandblaster makes it a pretty good analogy for sand in a brown dwarf.
In the atmosphere of a brown dwarf, the gravity is 300 times what it is here on Earth. And these little sand grains in the clouds would be falling at 70, 80, 100 miles an hour. It'd be a lot like a sand coming out of a sandblaster. This sheet of stainless steel has been warped by the force of the sandblaster. You can imagine the iron rain in the atmosphere of a brown dwarf coming down at 100 miles an hour, what it might do to a sheet like this.
These drops of liquid iron, they're maybe 2,800, almost 3,000 degrees Fahrenheit. These drops can really start falling at high velocity, 50, 80, 100 miles an hour. So you can imagine your umbrella would be torn to shreds by this hail of molten iron. It'd be a real rainstorm from hell. This has got to be the worst weather in the universe.
Heat, convection, condensation. The elements of weather. Alone, they cause spectacular rains, supersonic winds, and heat on other planets. Combine them, and incredible storms are formed.
A storm needs a temperature difference. On Earth, every storm is a result of uneven heating by the sun. The easiest example is the ocean is colder than the land.
Hurricanes, cyclones, and vortexes are the great wonders of weather on Earth. But also in space. And unlike Earth, where storms last hours or perhaps a few days, some storms in space can last centuries.
These hurricanes would make our hurricanes on Earth look like a summer breeze.
Neptune has the fastest winds in the solar system. But it also has a great dark spot. A mysterious hurricane-like storm that appears and disappears with no warning. It flies around the planet counterclockwise. Discovered by Voyager 2, it's big, with black and blue features. It appears to be a fierce storm, about the size of Earth. Scientists don't know what causes it to form or why it's black. It's a mystery, like another storm in our solar system. Saturn is famous for its magnificent rings, but is a little mysterious when it comes to its atmosphere. But sit back and wait 30 years, and Saturn will put on a storm so magnificent it would impress Mother Nature herself. It's called the Great White Spot, a gigantic storm that develops every 30 years on Saturn's surface, eventually covering the entire equator.
This is truly a planetary scale phenomenon, and we think it's a monstrous, monstrous thunderstorm.
Scientists have observed the storm developing at Saturn's equator, where it receives the most heat from the sun. Perhaps heat builds over time and finally bursts into a storm on a planet that has no surface or friction to slow it down.
In other words, it's sort of like a vicious circle where once you get the ball rolling, it just rolls down the hill and, the storm goes global.
Months later, the storm runs out of energy, only to lie dormant for another 30 years. What the cause or timescale means, scientists truly don't know. But Saturn's Great White Spot is not as powerful or everlasting as our biggest storm in the solar system. Jupiter has long been a source of fascination for scientists when studying wild weather in space. And its great storm has been a feast for the eyes for centuries. Jupiter is the giant of our solar system, dwarfing all other planets. So it's only fitting its weather also becomes a showpiece of sheer force and incredible size.
In 1664, the astronomer Robert Hooke noticed something strange about Jupiter. There was a pimple there, which we now call the Great Red Spot. It's been stable. Think of it. A planetary storm, several times the size of the Earth, stable since 1664. This is one of the amazing features of our solar system.
The Great Red Spot was named that long before we knew what it was, because you can see it from a telescope on Earth. And so for hundreds of years, people have known about this Great Red Spot.
The Great Red Spot is the most impressive storm of our solar system. And it's been churning for at least 300 years.
The mother of all hurricanes in our solar system is actually on Jupiter. It's not technically a hurricane, but it behaves very much like one. It has a heat source, it has swirling winds, but it dwarfs anything on our planet. This storm is so big you could take 2 Earths and stick them right inside the storm. The winds are blowing at 300 miles an hour.
Both hurricanes and the Great Red Spot are giant vortices. In the case of hurricanes, they're a low-pressure center. The Great Red Spot is a high-pressure center. In both cases, there are high-speed winds circling the vortex.
Like a giant eye, the storm continuously circles Jupiter. Wind speeds reach 400 miles per hour, and the giant red spot never seems to dwindle in strength. Powered by the internal heat of Jupiter, it also eats anything in its path.
If you're a small vortex and you're in the path of the Great Red Spot, look out. You're going to be gobbled up like a little fish.
Scientists believe the lack of friction or surface on Jupiter might allow this storm to churn uninterrupted for centuries more.
On Earth, because of the strong friction, when hurricanes hit land, they tend to fall apart in just a few days. On the other hand, the Great Red Spot has a lifetime of over 100 years. We don't really understand this in detail, but it probably means that the friction in Jupiter's atmosphere is very weak compared to an Earth's atmosphere.
Jupiter is a good example of a planet where the planet itself is what's supplying at least some of the energy to drive a storm that's lasting for centuries.
Weather, the state of an atmosphere. Throughout the universe, familiar weather events on Earth are played out in fantastic ways on other planets. But why study weather on other planets at all?
If you only ever study Earth for examples to understand Earth, you may be missing a much broader context in which the phenomena that you're trying to describe is embedded. So, for example, we look at Earth and we talk about a greenhouse effect. You want to learn about it, go check it out. Look at Venus. The urge is to believe that all your solutions to your problems on Earth can be found by only looking at Earth. That is short-sighted, bordering on delusional.
When we study familiar processes in unfamiliar settings, it really tests whether or not we understand what's happening.
In terms of the possibility of life on other planets, the understanding the weather patterns is absolutely key.
We're one planet of many. The sun is one star of many. We're in an undistinguished part of the galaxy. There's much to be learned by exploring what others say.